So what's happening at this point is I have just got here. Let's get things unbroken. Yes, it just got here, but you are here in the beginning, you know, because I was talking for 23 minutes in mute, so I was not talking to anyone. Nice. And later I will cut this out. Lol, yes. I will cut everything out. So let's do something so I can cut and the stream looks nice when it starts again in the YouTube. So wait a moment. Hello, welcome to my stream today. I'm starting right now. I was not talking for 23 minutes in mute. Anyway, the problem is when I play, if I play this level, whatever, the ship starts broken immediately. Okay, if I start this one, the approach, it's okay. So no problem in that level. Why? This is happening because in the level of the planet, the spaceship starts really fast. And I detect if the spaceship is broken by calculating the speed. The speed is calculated here. Sorry. What? This is not down here, maybe? Oh, it's here. So the impact speed is this, the ship velocity minus the old velocity. So it's the speed in this frame right now minus the speed previous frame. So if I stop abruptly, I have a big number here. And if I have a big number here, bigger than 30, I will break the spaceship apart. But in the planet level, when the game starts, it starts immediately at, I don't know, 600 speed. And 600 is higher than 30, so it breaks immediately. Why? Because the previous frame didn't exist, so technically the speed is 0. That's a simple solution. We just send old speed equals to speed in the beginning, and we don't have that problem. But somehow that is not working. This only happens at the end of the frame, so everything is calculated before. Maybe I can put this before the calculation of the speed and have a 1 frame delay on breaking the spaceship. But I have another problem with this. The problem is that the ship is not the only thing controlling the spaceship. The ship is one of the things that controls the rigid body. So this is a rigid body script. This controls the main node. The main node is a rigid body, and the rigid body is an element that has physics, whatever. But I also have the polar gravity script that also controls the spaceship, and because of this. So the polar gravity script controls the spaceship. It calculates the weight of the spaceship and detects everything around the spaceship. In this case, a planet or an asteroid or another planet, whatever. It detects all the rigid bodies that have a polar gravity, and they talk to each other, so they attract each other. This is what's happening. All of them react to all of them. Of course, if this is heavier, it will make the other ones go into that direction. This is what the polar gravity script does. But in the case of the planet, level, I have the planet moving there, and the spaceship is here entering the scene in that direction, so it's supposed to do this. We should be doing this. That's the purpose of the level. And to do this, I have to inject velocity here. It needs to start already with some speed, and I do that in this script here. The polar gravity script is the one. I cannot use the pen to do this. The polar gravity script is the one that puts the velocity into the rigid body, but it doesn't put the velocity into the rigid body here. It sends the velocity to the spaceship script, and the spaceship script actually does that. So this is not very clean. It has a lot of problems, and it's really difficult to actually understand if the old speed and the new speed is actually set up before the level starts, because I don't know. I'm not sure which one happens first, if it's the polar gravity or if it's the ship script, you know. So this is very messy. It's like this because I'm trying to build something that I don't know how to build. So we program the things where it makes sense to program at the point we program them. But now that I understand what's behind the spaceship and everything, I guess I need to clean this up and make this properly. Can you tell to count only after? Yes, I can do that, but that's adding more spaghetti to the spaghetti. I can tell to count only after the first frame, but that's not the best solution. That's adding more problems. You know, that's putting more tape on the fixing instead of actually fixing the problem. So yes, yeah, I know it's for the ship not to break, but no, that's not how it should be. So the thing should be like this. In the beginning, all the scripts apply the speed, and only after the speed being applied, I will start calculating the velocity, and I don't have to wait. I don't have to wait one frame to do it. It needs to happen at frame 0. So I was thinking, and instead of having these two scripts talk to each other, and I have here another problem. The polar gravity talks to the ship script. Where is here? This is nice. So I have some number to send to the ship, and I send to the ship. But if I want to use the polar gravity in the planet, this will give me an error, because the ship script does not exist in the planet. So you see, that's a problem. So what I want to do is to separate the functions into different scripts. Let's go here. What I want to do is something like this. The spaceship that is a rigid body will be controlled by one script, and this script only controls the rigid body. So this is the centralized way of talking to the rigid body and to get information from the rigid body. If I need to control the rigid body because I'm pressing up and I want the spaceship to go up, instead of doing as I'm doing right now, which is the ship script is talking to the rigid body directly, instead of this, I'm going to find a way of sending the information there, and this guy will handle these data transmissions when it's appropriate to do. At the same time, I have here a polar gravity script that also sends the information here. So if the rigid body needs to move because I'm pressing up, or if it's to move because it's being attracted to from another body, and it's not just one body. If I have 3 planets, I will have 3 polar gravities controlling this thing, you know. This script here will be the main physics controller, manager, whatever, I don't know the name yet. This one will be the one responsible of handling the information from this guy, from this guy, from this guy, and from this guy, calculate the direction and apply direction to the rigid body only once, instead of pressing a key, move, polar gravity, move, polar gravity, move, polar gravity, move, in one frame. This is stupid. At the same time, the ship script it only has the controls for the ship and the behavior of the ship, whatever. But I want to have, if I think 1 year in the future, maybe I want the ship to have the possibility of having a manual control or an autopilot control. Imagine a level where I'm controlling one of the ships, but the others are automatically controlled. So maybe I need to have a autopilot, and to have an autopilot, I need to control this script automatically. So instead of having the manual controls inside the ship script, I will have the ship script to accept controls from outside. Control, meaning this could be a manual drive or an auto drive. Manual control or auto control. So one script to input the thing, another to receive and calculate the behavior of the spaceship. It sends the data to the rigid body through this main script. All the rigid body controllers will do the same. And I'm actually separating all the things. In this case, it means that if the polar gravity sends, okay, start with this speed, the thing that will detect if the spaceship needs to explode or not will be after that. I will make sure. So no matter where the information of movement comes from, it will happen always after. Looks more complicated, but is simpler in the long term, and allows me to have manual pilot, autopilot, I don't know, semi-automatic pilot, because I can have features in auto and other features in manual. So I guess this is my new challenge for today. Separating these codes. And I guess the first thing is, let's read the scripts from beginning to the end and understand what's happening, and then start to plan where the things go. And then we start doing it. Sorry, let me put this out of the way. Okay. Okay. So, let's see the structure first. Sorry. Oh, let me... Okay, this will be an adventure today. My streams take 3 hours more or less, so today will be 3 hours and 23 minutes extra. So let's see if I can do this in the next 2 hours and something. I believe it's not very difficult, because everything is already done. I just need to separate them. I will not write everything again. I just need to make sure where the thing goes. So the structure of the spaceship is this one. I have the rigid body as the main node, so this is the one that I control in terms of movement, and this is the one that has physics. And I have inside the spaceship, I have the polar gravity. So everything that moves and needs to be attracted to each other will have the polar gravity script. And what I want, I already tried this like 4 hours ago, having a polar gravity ship and then a polar gravity planet, so they are different. But this also doesn't work very well, and it was, as I was saying, adding more layers of problem on top of the problem to solve the problem. So yeah, I will not do it this way, and I can solve that immediately. Polar gravity planet and polar gravity ship, delete. No more. Of course, this immediately created many problems, because now planet does not know what is a polar gravity planet. Well, let's try first to delete all these errors. And the ship does not know what is polar gravity ship. So I don't need to separate these behaviors into two scripts, because polar gravity is polar gravity. It should be compatible with everything. Save. Polar gravity ship, delete, delete. So I just need to have ship and polar gravity at this point. For now, I will keep the ship controls inside the ship script. I will not do yet the manual and auto mode. But as I was saying, instead of the ship talk directly to the rigid body, as I'm doing here, I will have the ship talking to another script, the centralized script that controls the rigid body. So let's start by creating that script. I don't know exactly how I'm going to call it. Maybe movement manager, physics manager. It doesn't sound good. It doesn't sound rigid body manager. Yeah, it could be that. Rigid body manager, and everything that needs to access the rigid body talks to this one. This one will do the thing, and this needs to inherits from rigid body to D. And our very weird part. This will be solved in the next version of Godot. But at this moment, I cannot see the parameters that I have in scripts inside the main object. For example, the spaceship has this script, and this script has all these variables that I can change when I'm in the level scene. But for example, the top thruster that also has a script and that also has a number to control, I cannot see this in the other scene. So station approach. This is the station approach level. It has a lot of things inside. One of the things is the spaceship that is closed because it's a scene, and I cannot expand this scene and control the engine force or whatever. If I want to change that number, I need to go to the ship and change it here. This has two problems. First problem, if I do it here, it will affect all the levels the same way, because this is inside the ship. While when I do it here, if I change ship allow backwards in here, directly in this will not change the ship itself. It only change the instance of the ship in this level, meaning that station approach will not allow backwards, but in the other level I can on this again. If I do this here, this will be the same for all the levels. And if they are hidden, I cannot change them back into each level. So this is a problem, a structural problem of Godot. And the way I'm dealing with is all the things I need to change are in this script, and this script communicates with the internals. That's how I do it. I don't like it, but I believe the next version, I read it somewhere, the next version will allow us to expand here. And when that happens, I can change the values of the controllers, the autopilot, or whatever the things are here. At this point, I need to have in the main node the things I need to change to adapt the spaceship to the level. That's kind of annoying, but we just deal with it, and yeah. If eventually, if in the future it's possible to expand the tree and change the things, I don't care. It's already working. That means, so going into the future a little bit, this was going back, that means that I cannot use that rigid body manager here. I wanted to use it here because it would control directly the node where it is, but I cannot do it because what I want here is to have the variables, the ship variables, or whatever I need to control to change the behavior of the spaceship. I can, but I don't like that, because that's exactly what I have right now. I can have the manager inside the ship and everything talks to the ship, but that's, yeah, that will create the problem of detecting the ship script and the planet doesn't have a ship script, blah 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 blah, so it's not very useful. So what I'm going to do is to have a script that will be here in the main node, this ship, to have all the behavioral settings. Nice. And maybe the movement mechanics being processed here, but this will communicate with another node that only has the rigid body thing, and that rigid body thing will look for the rigid body object to control it. It's not pretty, but it's the best direction, the direct route I have to do it. So let's create here another node. This will be just a node. This node will have, I'll put it up here, I will call it rigid body manager, and guess what, it will have the script rigid body manager. The rigid body manager, the first thing will do, that will do when enters the scene, so I need to enter the scene, the first thing. So we need another method here. Public override enter tree. So this happened even before the ready method. The first thing to do is to get the rigid body. this doesn't need to be a rigid body, I guess. Because this is not in a rigid body, so whatever. So the first thing we are going to do is to have a variable to get the rigid body, rigid body 2D, and it will be called rigid body 2D. And the first thing is to get it automatically. So rigid body 2D. Small letter in the beginning is the name of the variable. Big letter in the beginning is the type or the class. So my variable will be equal to get parent of type rigid body. And I'm pretty sure that now if I talk to the rigid body, I'm talking to the main node physics thing. Because the main node not only has physics, it has more things. If you look at the rigid body, you have this is my script, but you have the rigid body part, which is the physics, and then you have the collision object 2D. It has the node 2D, it has a canvas item, it has a node. So these are things that inherits one to each other. So I'm talking directly to the rigid body part, which has the physics. Save. Let's see if I print it. I cannot print there, I guess. Print. If I print the rigid body, let's make sure that this happens before everything. I will try to print in the enter tree. Copy paste. Print these letters. Copy. Save. Let's do it here on the ship enter tree. Paste. Ship enter. Paste. Ship ready. Save. Polar gravity ready. Paste. Polar gravity ready. Let's play and see how the things are ordered. What happens first? Let's see what happens first. Play, whatever level. So rigid body is the first thing. Yeah, nice. Then we have that thing that is inside the rigid body manager script. And then we have ship ready. Ship ready is the next one to happen. That's strange. Ship ready is the next one to happen. And ship enter does not happen before. Why this doesn't happen? Oh, I know why this is not happening. Because I have an error here. Polar gravity and ship polar gravity. Oh, yeah, it has the same name, but it has the wrong script. No, polar gravity is there. Polar gravity. Why the ship enter tree does not print anything?
Rotate towards target using the thrust.
See, polar gravity happens first, then ship. And polar gravity is inside ship. So it's kind of weird how or why we put the ship there and what's inside the ship happens first, then the main node. Oh, ship enter is actually the first one to happen. It happens before this rigid body. Okay, so okay, this happens first. Ship enter. So this thing, I need to do this so I can look at the, well, I'm in front of it, probably. No. Script, come here, script. So the first thing happens is the ship enter. So ship enter, this happens first. Second is a rigid body print. So the rigid body manager happens second. The third thing is this HJG, which is the ready of this script. So this script happens after the ship. But this is a very interesting thing. This is a very interesting thing. It's so interesting. Then we have the PG ready, the polar gravity ready. So after that, number 3 is this one, number 4 is this ready here. And then after everything, we go back again on the ship and this happens. So whatever needs to be set up in the polar gravity in the body manager will happen before the ship ready. But the ship enter will happen first. This is so strange because this is the same script. It's like, okay, this happens, then it stops here. It will do every other script that exists, and then it comes back here and continues from this point. Or these things are happening at the same time, but they are just being written here in this order. But I don't believe, because if this happens to be first, it's because it happens first. So this is a very complex problem. So this rigid body manager, at least it's the first thing to happen after the ship being placed in the world. So the ship happens to be placed in the tree enter, and we get the polar gravity. We set up the polar gravity variables that we have here already. So basically, the first thing happens is to set up the variables on the polar gravity. Okay, I accept that. And then we jump to number 2 is the rigid body manager, which is, I believe, it's happening first because it's above the polar gravity. Let's change the polar gravity to this position and see if this changes. Play.
Rotate towards target using a...
Ship enter, rigid body second. rigid body second, PG ready third. Oh yeah, it changes, so this is no longer the third one. So the position in the tree will make the order, but it's not the order of the script, because entering the tree is one thing, ready is another thing. So maybe it cycles all the enters first and then all the readies. Yeah, probably that. So what's above happens first. Chip enter rigid body, PG ready. This is ready of the this is the ready of the rigid body manager, and then the ship manager is the last one, which is very weird because this is the top one. So enter, I'm not understanding this. Enter is from top to bottom, but ready is from bottom to top. Yeah, this is so crazy. This is so crazy. Let me say this is what? Ready rigid body manager ready. This is super weird behavior. Well, probably is documented and everything. But when you are expecting the things to happen in one direction, it doesn't. But also it doesn't happen in the other direction because it depends. Play.
Start right lateral acceleration.
So ship enter. This is rigid body manager enter. And then PG ready, rigid body manager ready, and ship ready. I don't have enter in the PG, that's why I don't have anything here. But yeah, the enter method happens top to bottom, but the ready method happens bottom to top. Rigid body manager is the first one. Polar gravity, no, polar gravity, top to bottom, top to bottom. But I don't understand why the ship enter is the first one and the ship ready is the last one. Well, whatever. It's not important. What I'm going to do is to do whatever I said before, but keeping this in mind. I need to take notes in the paper because I will forget this. Do I have here something to write? I don't want to write on these papers because these are the original drawings of the game. Oh, I have here something to write. So, ship enter. Ship enter. This rigid body comes from the rigid body manager. Rigid body manager enter. Next we have the PG ready, the polar gravity ready. I need to test where happens the polar gravity enter. We don't have it, but we will add it just to test. So let's copy this, copy. Let's put this on the polar gravity. Let's delete this. Let's write here polar gravity, enter. So ship enter, first one, yes. Rigid body manager enter. Oh, PG enter second. Okay, because it's the second in the tree. Okay. So rigid PJ polar gravity enter is the second one. Then rigid body manager enter. Okay, is that so top to bottom. Next one is the PG ready. Then is the rigid body manager ready. Rigid body manager ready. And at the end of everything will be the ship ready. So if I have a script, an object with a script, and then two objects with two other scripts, it goes enter, 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 ready, ready, and then eventually ready. It's a very weird order, because this ready and enter cycles before that, maybe because it's a child. Okay, let's just, this is weird, but let's just keep this in mind when preparing the variables and the speeds and actually setting up the thing, because the spaceship at this point is exploding because of that. Some number is happening before or after the place it should be happening. Okay. So rigid body manager will be the first. I want this to be the first to be set up. Polar gravity will be the second one, and then eventually we could have the control, the manual control, or the whatever happening after that, but that's not important at this point. So this one does not talk to, this one cannot talk to the rigid body anymore directly. So all of this code here, get input, process movement, process visuals. Yeah, process visuals can be here. Check that this is not being applied at the moment, so maybe this will happen in another place. Process movements can be here, process visuals can be here, but there is a part of the process movement that will not be here, because process movement is calculating everything, blah 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 blah, and at the end apply torque and apply force. So this is talking to the rigid body. So force direction and torque. Force direction is being calculated. Where is this being applied? Up here. Force direction is whatever calculation I do here, blah 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 blah, and then I send it to the rigid body. And torque, the same thing. This is for the rotation. It's being calculated here. Oh, it's being declared here. I don't like it, because every frame this variable is created and renewed. So I can declare up there, and it's always available since it's always used. So this goes to the other script. Apply force, apply torque, which is not like this. Let's copy. paste. Rigid body manager. So let's remove this thing. What we are going to do, and this needs to happen in the process physics method, not process physics process method. Paste, apply force and direction and torque. So this needs to come from outside. Or at least this will be the last ones to be applied, and I need to calculate here. So let's write a comment. Get info from player input. Get info from polar gravity. Polar gravity already calculates inside all the other polar gravities, so I just get one number. And last step is to calculate player plus gravity, and then eventually apply. I apply once only. So this polar gravity also will not talk directly to the rigid body. So this cannot happen here. This cannot happen here. And maybe this is because I have two scripts talking at the same time to the same rigid body. Maybe this is why the velocity calculation is not consistent. Because maybe the velocity calculated in the other script calculates the velocity before this guy applies numbers. So the velocity is actually different of the one we get the result. Very complicated, but if we do it here, we actually just apply once the speed, the direction, and we can have the numbers before applying them or after applying them. So we actually have just one number with the final result of the speed and the torque if we need the torque. Of course, we cannot do apply force because this does not talk to a rigid body. This is not inside the rigid body, so we need to call the rigid body first. So rigid body to the dot apply force, play paste. So this will work. This is a constant because the forces needs to be a big number, but I don't want to deal with giant numbers, so I multiply here by 1000. So I kind of have easier numbers to work with, humanly speaking. And then eventually I multiply it before, at the moment of application. So this can be here, and I don't need to test it or to change them. This is just a constant to have more zeros at the end of the number. Okay, so now force direction does not exist, torque does not exist. I will change these names. This will be, how do I call this? Definitive torque and definitive force. Final force. Final force and final torque. Final. This look like my students' project files at the end of the semester. Final underscore final, real final 2. This is the one. So final torque will be the last one and is the one that will be applied. So this does not exist. Final torque, final force. Let's declare it. Final force is a vector, yes? Yes, is a vector. Is a vector 2, final force. And the other is a float. Float, final torque. Okay. Now we need to have public ones. So I can receive the numbers from the polar gravity or from the ship. So public vector 2 ship force and public float ship torque. But I understand you should have someone to name final countdown. No, I cannot name it final countdown because I will have a copyright strike. I'm joking. No, final. But I understand your students. I also did it. Yes, we all did it. We all did it. I no longer do it. Get a career in teaching and you will start to hate this. Like, it's really bad. Really bad. Students, I know you are listening to this stream. Don't do it. Not final underscore final, please. So public vector 2, and this will be polar gravity force and public float polar gravity torque. Yeah. The real final one is always it doesn't have the final name. It's no longer just final. And what I teach to my students, and I actually do, is like I don't know, the project is about potatoes. I start the project and I call it potatoes 1. If I need to iterate, to change, to deliver something to the teacher or whatever, or I know I need to change the project, and I prefer to save as, not to destroy the first version. I will save it as potato 2 and potato 3 and potato 4 and so on. So on potato 345, I save as potato final and deliver to the teacher. That's it. Whatever I deliver to the teacher will be called final. My iterations is numbers. That's how I rule. So I always know which one is the last one, and the teacher always knows which one is to be evaluated. So it's easy, so easy. I don't understand the underscore, double underscore, final. Anyway, so now I have here the vector. This comes from the spaceship, this comes from the polar gravity, and we just need to sum them together. So final force equals to ship force plus polar gravity force. So easy, so clean. And final torque equals to ship torque plus polar gravity torque. That's it. the engine is pushing there 1000, the planet is pushing there 1000. The thing stays balanced because 1000 plus minus 1000 is 0. We apply 0 and the spaceship does not fall, but also does not go forward. Makes sense? It's easy, very easy. So we just sum the forces here. We make sure, and I guess it doesn't matter which one is on the right or the left side, who cares? And we apply it here. At this moment, if we need to calculate which is the speed of the spaceship, we can do it from here. Calculate speed, and then that's it. We know that what we have is a final speed because we already applied everything. So now, no matter the order of the other two scripts, they will send the numbers here and the other will send the numbers here, and this will be applied considering both directions. Okay, at this point this is okay. I believe I need more things, but I'm not. So this is done. Getting info from player. Getting info from player, this is wrong. It's not getting info from player, because the player will write the info here. This will not talk to the player will talk to the rigid body manager. So maybe now I need to have, or I access directly because these are public variables, and I can just say the rigid body manager dot polar gravity or whatever, and I'm talking directly here. Or eventually, if I really need, I will do a method to inject the numbers. At this moment, because I only have one ship script and one polar gravity script, I guess I can access directly. If it was to be many scripts, the method would be nicer. I don't know. Okay, so now the ship, this will not happen here. So this force direction goes, we need to talk to the rigid body manager. Means that this script needs to have access to it. Rigid body manager, rigid body manager, and we will get it. Let me look at the order. Ship entered. Oh, this is the last thing to happen. But this needs to happen in the ready function. Because here, this happens before. Oh yeah, but I'm just getting the thing. Okay, I can get it here. Rigid body manager equals to get is the same thing as this one, but with this name. Rigid body manager but the relative position should be important. Which relative positions are you talking about? You are talking about the pull of two objects being the same in different directions. Yeah, it's like a scale. If you have the same weight in both plates, the scale is centered, you know? So that's why we sum together one force with another force. So it's an addition, mathematically speaking. If this is stronger, the thing starts to go in that direction. Okay, so we get the rigid body manager, and down here, where is the thing? It's here. Instead of apply force blah 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 or apply force blah blah blah, we are going to say rigid body manager dot for ship force will be equal to force direction. And rigid body manager dot I guess I need to do something in the other one. I remember I'm looking into the future and I'm seeing something. Ship torque equals to torque. Okay, so at this moment it should behave the same, but this script no longer talks to the other one, to the rigid body. This process movement is happening inside physics process, but because I'm no longer processing physics here, maybe this can happen in process. So this will be faster and it happens more times per second. For example, this local velocity and this needs to happen in the other one, and we need to get the numbers from there. So we are actually seeing the local velocity after the velocity being applied. Okay, yeah, there's a lot of stuff to change to the other script. Yeah, we need to go line by line and make sure. Anyway, what I was seeing in the future is, imagine that we are, oh, this will not happen. This is not a problem. Because I'm summing this one with this one, imagine the spaceship being exploding. So now I'm summing, the last number here was 20, and then the spaceship exploded, so no longer, there are no longer updates to this number, so I'm always summing with the number 20. This could be a problem if the things were outside of the ship, but this one is inside the ship, this one is inside the ship. So I believe that if the spaceship explodes, this will disappear. So that's not the problem, at least in this situation. Yeah, we need to get this angular velocity from the other side and not directly from the rigid body. For now, let's keep it here, and let's see if I can still control the spaceship.
Prepare for main engine burn to decelerate as you approach the station.
Yes, I can. No. Rotating fast is not moving fast. We need to make it explode also if it's rotating super fast. Okay, so this is working. Sending the numbers there. Sending this number here and here being the place where the thing is applied. It works. It's not very clean because this is sending the numbers there, so this one can talk back and control that, you know, but yeah, at least we have a centralized way of doing it. So now let's make polar gravity also talks to that one. Polar gravity. Polar gravity. Polar gravity. The polar gravity is apply central impulse to rigid body parent, which is a variable. Yeah, it gets the rigid body directly. So we will change this. We need to have an axis is like this one. Go up. Whoop. We need to have an access to the rigid body manager from the polar gravity. It could be this in this place here. And we need to start it in the ready function, or in the enter function. We get that like we did in the other one. Is in the enter tree. So polar polar gravity. We need to change this eventually. Copy. Rigid body manager. No. Polar gravity, enter tree. It gets the rigid body manager. So now everything that needs to be calculated in the polar gravity will be transmitted there. So I just need to substitute this parent rigid body from rigid body manager, because this is the same. Apply forces to the parent rigid body to attract in towards the target. Okay, so this needs to be the rigid body manager dot apply central impulse, but I'm not applying the central impulse. I'm changing the variable. Oh, maybe this cannot be done this way, because an impulse happens for a brief moment, and apply force applies a position force to the body. Force is time dependent and meant to be applied every physics update. Okay, and apply central impulse. Applies the directional impulse without affecting rotation. Okay, an impulse is time independent. Applying an impulse every frame will result in a frame rate dependent force. For this reason, it should only be used when simulating one-time impact. Yeah, I can use the other force. I don't know why I did this central impulse. Oh, I know. Yeah, I know why. I know why. I did an impulse because if I have 30 planets around me, I need to have an impulse for each one, because this is enough for each body. It will impulse a little bit into that direction, and it depends on the force. That is a calculation from the mass of the other body, blah 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 blah. So I need to make all the calculations before I apply the force. So this for each will sum all the directions together, and after the for each I will say rigid body manager dot polar gravity force will be equal to, I need to create a new variable here, gravity force. Gravity force. Gravity force does not exist. Whoop, 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 whoop. So let's create here a float. Gravity force is a vector 2. Vector 2. Gravity force. Rigid body manager does not exist because it's a big M. So now we need to calculate this gravity force, and this gravity force will be the sum of all of them. So maybe we just do something like gravity force equals to a new vector, so an empty vector, and for each object in the list of objects we do gravity force plus equal to this calculation. So gravity force will increase the force of every object. If I have 1, it will be 1. If I have 30, it will be 30. And when everything is calculated, it sends the gravity force to the rigid body manager. And I believe I don't have to change anything else. Let's see. For each target, I create a direction, which is the target global position minus the parent, so it gets where the thing is, there. Then it will calculate the distance there. If the distance equals 0 continuous, so it will ignore if we are dividing by 0. I believe, if I'm not wrong, if we are divided by 0, it will give 0. And then force magnitude will be a gravitational constant, which is this number, big number over here, times the parent, so whatever, the planet mass, times the target mass, so our weight and the other weight, divided by the distance. So you see, if it's far away, it will be less attractive. And that force is the direction normalized, so where it's pointing, times the distance, the magnitude. So this calculates how much attraction I have in which direction. And then I put that number here. I increment this to that number. So the next one is pointing in this direction. So plus 100 minus 100, gravity force will be 0. So if you have two planets and the spaceship is in the middle, it will not fall to none of them. But if it's closer to 1, it will start to fall into that direction. Because I will sum them here. When they are all checked up, the number will be sent to the rigid body manager here. That will be summed to the inputs of the player, and we apply that force to the rigid body in one single number. Nice. So to make sure we are getting, because we can get that at any time, we can write here. So I'm in the ship script again. At any moment I can go, where is the thing? Not here. This is input. Where is the, oh, it's here. So at any point I can get this angular velocity, rotation degrees, local velocity, but I'm not sure if this is being read before applying the thing or after applying the thing. If it's read before, it has 1 frame of delay. If it's read after, it's correct. So we need to get this local velocity, rotation degrees, and angular velocity from the other script. And not only from the other script, but after these lines, from here. And to make sure I'm reading them after applying all the movements, I will get this local velocity, which is a linear velocity rotated. So this needs to happen in the other script. This needs to happen in the other script. Copy. Local velocity. It is not being used anywhere. Oh, it's being transmitted. Okay, this is just to be used on the panel. So I guess this is not very important. But where is the broken spaceship? Broken ship. Okay, it's here. Broken ship. Instantiate broken ship. Impact velocity. This impact velocity, ship velocity, yeah, comes from ship velocity comes from this linear velocity comes from the rigid body. Yeah, this needs to happen in the other one, not here. We can get the number here, or maybe we can get the number after the process, whatever, because we need to move first. Ship velocity. Yeah, this will be very complicated to solve. I don't want to rewrite the scripts again, so let's see if we don't lose the logic here. So ship velocity this is a variable. Yes. Shift velocity math equals math absolute linear velocity dot length. This comes from the rigid body. So rigid body manager dot linear velocity, and this linear velocity will be low L. And now let's create this variable on the other one. Public float linear velocity, and we set up this linear velocity after applying the force. Linear velocity equals to rigid body 2D dot linear velocity. This is not a float, it's a vector 2. So this linear velocity actually happens after we apply the forces. So this number will only exist after we apply the forces. Anyway, this needs to be after the process input. Check input, impact, check impact. What? For now, I will not check impact. So ship velocity get it from the rigid body manager, and local velocity uses the linear velocity dot rotate. The linear velocity is what? The body linear velocity in pixels per second, and this comes also from rigid body linear velocity. So let's do the same. Linear velocity, we already have linear velocity, so we just need to copy this, paste. That's it. Now we transmit local velocity. Okay, rotation degrees, this is not yet calculated, and angular velocity. So let's go to Godot and see if the thing is still working, because I don't want to make a lot of changes and then eventually I break everything.
The main engine burn to decelerate as you approach the station.
And I don't know where the broken part is. So yeah, the numbers are there, they are changing. I guess I'm transmitting the velocity correctly. And rotation still happens. Okay, nice.
Now ready to maneuver into docking position.
So I have a lot of stuff here too. This comes from where? Polar gravity. Yeah, that's a future problem. Now we are dealing with the ship. So ship still rotating. We get the input, we process the movement. Eventually we send, this is ship velocity. We are using this where? Oh, to get the impact velocity. So this is being calculated here from the other script already to get to check the velocity for the impact algorithm. Nice. Game event, we transmit this current movement. We transmit the current movement using the local velocity that already comes from the rigid body manager. The rotation degrees, this does not come from there. Rotation degrees comes from the rigid body directly. So rotation degrees is the next one. Let's go small r. So rigid body dot rotation degrees, and rotation degrees does not exist in this one. So let's do it. This is a float. Float rotation degrees. Save. So the error disappeared. Yes. And our rotation degrees comes from rigid body to the dot rotation degrees. Oh, come on. Save. And last one, angular velocity also comes from rigid body to D. So let's do the same thing here. Copy, paste. Angular velocity is also a float, a single number. Public float angular velocity. Angular velocity equals to rigid body to D dot angular velocity. Done. Okay, so this is done. Old ship velocity will be equal to the new velocity. And next frame will start again. And when we check the impact, we'll be comparing these two numbers, the new one and this one. Okay. Here on the input thing, nothing from the rigid body. Everything starts with a small letter, so nice. Nice, 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 nice. The sound and process movement. Convert input vector to local space. I'm using here transform. That comes from the node to the, okay. It's not very important, because this is just to detect the, no, not important. No, input, trust, sound, if input, fuel waste, if fuel, move the thing. I don't see, apply forces no longer happens here. Apply forces, more or less. Old fuel, and that's it. Disable the the engine visually. Check for impact. We are not reading anything from the rigid body. And global position. We are reading the rigid body just to instantiate the broken chip in the same position. And this comes from, no, this doesn't come from the rigid body. This comes from the node to the and what we are reading is the linear velocity that we can read from the other one. Now, so rigid body manager dot linear. Yes, that's it. And ship instance, I believe, let me see if this works, but I believe I don't need the rigid body anymore in this script. Let me check if it's still working.
Prepare for main engine burn to decelerate as you approach the station.
I can stop. I can change direction. The numbers are changing the panel. The fuel is being wasted. Can I rotate? Yes. Spin rate, rotation, everything is working properly.
Use thrusters to align with Dock 2.
Drifting the spaceship. Everything is working properly, means that maybe I don't need this ship one to be inheriting from the rigid body. Let's try. I have here a bug. Mass. I need to get the mass. Oh, I'm setting up the mass. I'm not reading. I'm setting up the mass. This is happening in the ready function. So mass, let's put, I could do this in the beginning, like removing the inheritance, and I will have red lines on each one that I needed to change. Anyway, mass could be the first one. Rigid body, mass. Public float mass. What I'm doing here is setting up the mass. This is happening in the ready function. I guess I need to do this with a method public void set mass float new mass. And when I call this, I will say rigid body to the dot mass equals to new mass. That's it. And here we just say, where is the mass problem? Instead of mass directly, we will say rigid body manager dot set mass with this number. That's it. Let's go to Godot and see if the game is still working. Maybe not. Maybe not. Let's see. Maybe not. Rigid Body Manager 32. Rigid Body Manager 32. Okay. I believe this needs to be a rigid body anyway, even if it's not talking to the rigid body. Because when we get that from here, if the script inside doesn't inherit the same, let me see if the error disappeared before I finish this sentence.
Prepare for main engine burn to decelerate as you approach the station.
Yeah, even with the script not controlling directly the rigid body, because it's not, nothing controls the rigid body from this script. When I'm in the body manager, when I call get parent rigid body, if the script that is there does not have the same type, I guess it doesn't find it. But I'm stubborn and I want to. Let me try something. Export public. I will not get it automatically. I will put the rigid body there manually, and the ship will not be a rigid body. Node to the. Just because I want to make sure. So, body manager build. We'll reference the ship. Does it work? Play, continue, quattro, play. No, it doesn't work. Very nice. Even when I put it there manually, it doesn't find the rigid body because the script that is inside there is not the rigid. It does not inherit from the rigid body, which is strange because this script is not talking to anything inside that script. I guess this is something that I bring from Unity, you know, because in Unity you can have multiple scripts, different scripts inside the same object. So who cares about the inheritance? Well, but I guess in Unity all of them inherits from mono behavior, so they are all the same thing. Oh, they are all the same parent. So, and if it's this, it's not a node to D. Oh yeah, it needs to be a node to D because error in the rotation, error in the transform. So yeah, the node. No, okay. Let's not complicate our our problems. So this goes private again, and this exists again. Save, play. Play, and the spaceship should be moving normally.
Prepare for main engine burn to decelerate as you approach the station.
Okay. Moving normally. So, the controls are no longer happening here. The polar gravity is no longer happening there. Both are being calculated one on each other, but they communicate the thing here. And this is the only one that talks to the rigid body to apply forces. But now I need to make sure this is actually working. So let's create a fake. I guess this will not work. I guess this will not work, but anyway, let me try anyway. I guess I already have here a fake level to test stuff. Docking first, later, lateral lock tests. Lock tests, no. Orbital turn. No, I don't have any level to test stuff. So let's create a new level. Let's add here the spaceship and the planet and see if they attract each other. So where is the elements? Screens, elements, ship 1, and the planet. Where is the planet? Planet 1. So they should fall 1 inch into the other. Let's put the camera because we need to see it. Camera. And the camera needs to be a little bit bigger. Whoa, like this. Save. Let's call it test scene levels underscore test scene. So it's always at the top of the list. This maybe will not work. Let's play and see what happens. $147 errors because make sure the script which script planet element. Okay, next one, rigid body manager relative to the polar gravity. Oh, I didn't program polar gravity yet, I guess. Node not found. Rigid body manager relative to ship 1 polar gravity. Let me look at it. Polar gravity. Rigid body manager is here. Of course not. Of course not. Because rigid body manager, it's not the parent of the. It's not the child of the polar gravity. So before getting the node, we need to go up. Let's look here. Sorry. This is the polar gravity. This is the rigid body manager, and this is the ship. In the ship script, we get the node. but in the polar gravity we need to get the parent to then get the node. So we need to go up before we get the node. So get parent, dot get node. Nice, but somehow they fall forever into the infinite. This is very nice. Let's start again. Let's do something different. Let's put the spaceship a little bit more here. Let's put the camera with a little bit more zoom. I will try to accelerate. See if I can get into orbit before I fall. F6. Almost. Can I? I cannot. Oh yes, I can. So I'm in orbit. I'm always falling, but I'm fast enough not to fall forever. Not to fall, actually fall. Oh, let's try to stabilize rotation. Oh, okay. Very nice. But as you can see, the planet is also moving because the gravity of the spaceship is also affecting the planet. Of course, the planet has more weight, and because of that, it's not being affected so much as the other one. Yeah, the thing is working. Let's do another. Let's add another. Oh, I have an option here. Where's the planet? But I can say is stationary, so it doesn't move. No matter what we say, it will not move. So let's add another planet and see if we fall into each other. This is actually what I'm going to do, is actually the name of the game. Free return trajectory is when you start to fall into one planet, but you kind of slingshot around it and start to fall into the other one, and slingshot around and start to fall into the other one. This is what a free return trajectory means. So if the spaceship is at the center of both planets, I will try to make them more or less centered in the world. The camera spaceship goes here. It shouldn't fall, or at least it needs to be perfectly in the center. Maybe I can do that. Planet 1 position, let's go 1/400. The other one will be -1/400. Okay, now this will be 6500. The other one will be -6500. And the spaceship will be at 00. So technically they are balanced, completely balanced. The spaceship should not fall. Both planets are stationary, yes. Object mass 1, and the ship has how much? Where's the mass of the ship? 1000. Oh, something's very wrong here. Anyway, not F5. F5 is to play the game. I want to play this scene, which is F6. Yeah, I don't fall. I'm balanced between those two bodies. They are fixed, so they will not attract each other, or they are attracting, but they are not moving. But if I move just a tiny bit, I will start falling into one. Let's go, and here I go. Bam. And then I continue to push it because the polar gravity is not working the planets. Anyway, let's go. Start again. Let's try to get a free return trajectory. No, 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 no. Again. I fall too fast. And you are back. Okay, so much time to get that ice cream. See, this is what I was talking before. If I'm exactly in the middle of two equal planets, I will not fall. But if I'm not balanced, I will start to fall. Bam. Okay, so now let's see what the bugs are and solve the problem of make sure the script file name exactly. This is relative to planet 1, whatever. So let's check the planet 1. Planet 1. Planet 1 had, oh, okay, polar gravity has the wrong name. Polar gravity has the script. What? This script is not the polar gravity script. Polar gravity. There. And we need another thing, because if we need to move the planet and the polar gravity no longer moves the planet directly, we need to have also the rigid body manager. Copy. Planet 1, paste, save. Planet 1 mass, let's go like 99999, super heavy, and the spaceship will be less. Wrong play. Let's see. Wow. What's happened? This is my new wallpaper. I delete the camera. Oh no, sorry, stupid. I play the scene of the planet. Test scene. This shouldn't happen. Oh, more bugs. So, polar gravity planet relative to node not found. Polar gravity planet. I forgot something. Okay, let's see. Test scene, play. Don't fall. Bam. It's very weird because I'm being attracted to this line over here. The line between them. And if the spaceship is here, what happens? Free return trajectory. I go from one to the other without wasting fuel. Oh. If I'm pointing forward when I accelerate at high altitude, like here, I can actually escape the planet. Bam. Let's I would like to have something that fix the the planet is not. Oh yeah, this is planet 1. Okay, sorry. Save. Test scene. Planet 1. Yes, why escape the planet when you can push it? Yeah, that's exactly the problem. It shouldn't happen this way. The thing is, I believe I didn't program this yet, so let's make sure that the polar gravity and the planet body is actually so polar gravity. It gets the polar gravity just because I don't need to talk to the polar gravity. That's the thing. The planet script, it's here only to have variables, nothing else. It will not be controlled. It has a start local velocity if I need the planet to be moving in the beginning. I need to have a stationary thing to lock the position. Maybe if this is true, I will just make sure the rigid body stays in the same position. Actually, the rigid body has an option called something called freeze, so it doesn't move. If true, the body is frozen. Gravity and forces are not applied anymore. Yeah, I just need to enable this if I want the planet not to move. Let's try. Save. Let's see how this behaves now. Can I push the planet? Not only I cannot push the planet, but this solved the problem of me being attracted infinitely there. Very nice. Oh, I'm imagining a level where you need to actually make the proper angle and force to go around all the planets. Could be interesting. Do you know how that mission can be called? Voyager. Because it was what happened with Voyager. They kind of point to the first one, to slingshot to the second, to slingshot to the third, and so on and so on. but that happens at a precise time where the planets were kind of aligned. Anyway, returning to our problem. Let's look at the script again. So this stationary false or true, that is something that I can set up here. I can also set up here. Because this is available. It's a little bit hidden, but is available. So maybe I will make this one, activate this one automatically. So I don't need to open menus. If it's on, it's locked. If it's not on, it will move. Okay, so let's do that. One thing at a time. So if this is stationary, the polar gravity no. I'm doing the problem again. This will not talk to the polar gravity. This will talk to the rigid body manager. So rigid body manager needs to have public boolean stationary, or maybe because this is setting up the thing, I will do as I did this one. Set stationary. Boolean freeze. So if it's on, freeze is on. Okay. Come on, lol. Of course you can. You are excused. And don't smoke. That's bad for your health, as you know. Anyway, let's go freeze rigid body dot what? See you tomorrow. Rigid body dot deactivation freeze. Yeah, it's just freeze. Freeze mode. So freeze mode. Freeze or freeze mode? Freeze equals freeze. Copy paste. And in the planet script, in the ready function happens. This is what? This is the ship or the planet, whatever. It's the last thing to happen. Okay. So ready public override ready. The ready function we just do I need to have that, where is ship rigid body manager. We need to get it in the ready function. No, in the enter tree function, rigid body manager. Let's get it. And eventually rigid body manager dot set freeze set stationary. Okay, set freeze. I will change this name. Freeze. Set freeze. Save. Planet to set freeze as, come on, as what? As freeze. And this will be called freeze. And polar gravity stationary. No, this polar gravity is start velocity. This doesn't need to exist. So when the thing starts with a velocity and in the ship is the same, start velocity, it's something that we send to the polar gravity. Because the polar gravity, where is the start velocity? It will calculate the direction of the rigid body, a vector, whatever force it needs to do, according to the rotation and position. So it gets the global transform with canvas, so how much is rotating from the x-axis, which is this axis. Oh no, x-axis is maybe the x-axis is this one, rotates. Yeah, x-axis is where it's pointing. I don't remember. Blah blah blah. And it adds the start local velocity according to that direction. So it's sum to the x, sum to the y if it's tilted. And then this parent rigid body, this talks to the rigid body. And so this is not pretty. So we are sending the rigid body the starting velocity from the polar gravity. That actually, we can just add this to the rigid body manager. So the rigid body manager can have here a starting direction method. And if we need to start the thing moving, we do it directly in the manager of the rigid body. So when we get those velocities, we already know the direction. Instead of sending the numbers from one script to the other and then go back to not very clean. Anyway, at this point I just want to lock the planet. So let's play and see if the thing freezes by itself. Let's unfreeze it. Okay, save. Now let's go on the test scene. And this planet can be, let's build it because the wrong, not this button. It will build it anyway. Go out. So the first planet will be freezed, the other will not. Let's see what happens. Oh, the planets, if they were loose, oh no, yeah, ignore what I was about to say. The planets should be attract each other. But technically one of the planets, it's not freezed, but it's also not moving. It's moving now. So this planet should fall on that planet. Why? Something is wrong here. So planet, maybe the mass is too big, and when the mass is too big, save test scene. Planet to 8888, same to the other one. Maybe when it's too big, it has some no drag, I guess. No damp, no drag. So maybe freeze mode, static or kinematic. Static means that if it suffers an impact, it doesn't move. Kinematic is the behavior we were having there. If it gets an impact, it will be moving, but it will not move by itself, only if it's pushed. So the polar gravity is not getting the other ones. Let me see. How is the polar gravity getting the other ones? Targets. Where are targets? Targets is a new list of rigid bodies. Okay. And target is being for each node in all rigid body nodes. These all rigid body nodes returns the scene tree that contains this node. Oh, come on. Of course, it's not finding the other ones. We need to find everything in the main node. Returns the scene tree that contains this node. Or the scene tree is everything. And returns null and prints an error if this node is not inside the tree. Okay. Let's print RB. If node is rigid body in RB and RB it's different from parent rigid body. What? I don't remember why I need to test this. Let me think. So for each node in all rigid bodies, in the list of rigid bodies, and that list is get okay. This list comes. Let's print all rigid bodies. So Godot.print Let's see what we have in all rigid body nodes. So we have three polar gravities. Let me do another print here. Because we have three polar gravities, so we will have three prints. And this is just to make sure if it prints separate lines when one starts and it ends the other or whatever. Save, go back, play. Go out. But what? Why? Just one polar gravity is printing, and it actually finding three rigid bodies. So this what I was expecting: the ship, one planet, and the other planet. But which one is printing? The ship one, because it happens before the ship is ready. And the planets are not printing. Let me look at the planet. Rigid body, poly it has the script. Yes, it has the script. Polar gravity. Polar gravity should print the list. So this is not happening. Also, what I'm doing here, I will add all the rigid bodies to the targets. When I'm calculating the directions, I'm seeing the target's rigid body. And I calculate the mass and the distance from the rigid bodies of the others. So I'm not actually connecting one polar gravity to the other. I'm using one polar gravity to check all the rigid bodies around. And if all of them, okay. Oh, now I remember why this is here. Because I don't want to add the self rigid body to this list, or else it will attract itself to itself. So if the node is a rigid body and the rigid body is different from parent rigid body, I will add the thing. So the addition to the list only happens if it's not the same, if it's not the parent. Parent rigid body is get parent rigid body, get parent of polar gravity, which is, yeah, the main parent. Okay, this looks nice. But now, if parent is different from null, so if the parent exists, I guess this doesn't need to be here. Because the parent exists always. Gravity force. I don't know where this gravity force comes from. Oh, okay. Yeah, it's not coming from anywhere. It goes to the other one. Okay. Gravity force is cleared in the beginning of the physics process. Then for each target, we calculate the distance and the force, blah, 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 blah. And we put everything together. Eventually, we send the force to the self-rigid body manager. Something is wrong, but I don't know where. Wrong play. Yeah, wrong play again. It's not the planet. Come on. Test scene. Play. One of the planets should fall into the other. But it's not falling. Let's debug this. So planet enter tree, object reference now set on instance of an object. Which reference? Line 15. Planet, line 15, polar gravity. Of course not, because I removed this. Why did I remove it? Polar gravity. Equals to polar gravity called polar gravity. But the problem is rigid. This is what? Planet. Okay, planet is a node. Planet is the main one. Okay, save. Let's see what happens. Not falling, but less errors. So let's see what's missing. Unable to cast object of type planet into ship 1. I already had this error, but I thought I deleted the line. Polar gravity 43. 43 on polar gravity. Okay, no, it's not. Save. This will not happen that way. Let's see if the errors goes away. Aha, planet is falling. Now it's working. Everything falls into each other. The left planet is fixed, so it will not move, and the other one falls. Can I push the planet? No. So let's try to escape from both of them. But now I'm not being attracted to the planet. Yes, I am. Okay. So let's fix the second planet. If I release both of them, I should have both of them falling into the center. At this moment, I believe I'm in a free return trajectory, which is the name of the game. Or not, I will fall. Bam. Can I take off from here? Maybe. Okay. Let's be more aggressive with the planet's gravity. So let's add another 0. See what happens. Bam, I'm dead. Okay. So now the thing looks like it's working. I will try to do something. So planet 1, which is this one, I will give it a push up. So negative minus 10,000. Let's see what happens with 10,000. And the other one will have 10,000. So this one goes up, this one goes down in the beginning, and because they are falling into each other, they should be orbiting each other. And the spaceship will be a problem, but yeah, let's see. Play. Maybe 10,000 is not enough. Yeah, it needs to be more. A lot more. So that's another 0. 100,000. Play. Let's see if they are orbiting each other now. Yes, they are. I believe I didn't enter this number. Yes. So this is too much. Let's say 5 0 0 0. How many zeros? Okay, 50. 50 here. Enter. 50 here. Enter. Okay, the planets are orbiting each other. Maybe 50 is too much. But they are locked into each other. Let's go 30, 20. No, I guess I believe the polar gravity is working. 20 is too less. They fall into each other very quickly. Let's go 30. Enter. Minus 30. Enter. I want to see them. And they fall. Okay. Or maybe not. Can I escape these planets? No. It's very difficult. I don't have enough force to escape the planet. At least rotate it backwards. Okay. So I believe the polar gravity is working. It behaves as I was expecting to behave. Of course I don't have drag on contact, so it's like they are made of ice. with zero drag, so when the ship touches, continues with the same speed. But if it has materials and if it has a little bit of drag, it's enough to, when you fall, you stay in place, not continue flying. Yeah, they are orbiting. Can I make a moon around the planet? Probably. I don't have another planet here at the moment. So I don't have bugs. I don't have the polar gravity is actually working. I don't like how the starting direction starts, because we set up the numbers here, but then we transmit the numbers there to be transmitted there. Is a mess. So the thing is working. It's not just in the right places, so I need to change that. And let's see. Now let's get to the normal game and see if the spaceship still explodes. Where is the spaceship? Spaceship. I had here an option, I guess. Oh no, I comment in the script. Ship, impact, checked impact. Let's check the impacts. Check impact. I don't know why I need this. I don't need this. Why do I have this variable here? So check impact will pick up the ship velocity that comes from the other script, okay, and will subtract with the old ship velocity. Nice. Old ship velocity. So this ship one happens, is the last thing to happen. So the ready function, the ready method of this script happens after the rigid body manager sets up the velocity. So technically this linear velocity is already the moving speed of the moving velocity, meaning that if we inside the ship we check the at the end of the ready, we do this: old ship velocity equals to rigid body manager dot what, linear velocity dot length, because this needs to be a float. If I do this here, I should have, when the game starts, I should have already the speed, the current speed, offsetted to the old position. Let's see if the spaceship explodes in the beginning or not. Check impact. So we do the math, and if it's above the number, it will break the spaceship and it will play the sound. Okay. Let's see. I believe it's not yet there because I'm not sure. I didn't verify everything and I'm very sleepy, very tired, and maybe I'm forgetting an entire script. I don't know. So if the spaceship does not breaks in the beginning of this one, I guess
Prepare for main engine burn to decelerate as you approach the station.
we are in the good way. Let's see if it breaks.
Use thrusters to align with dock 2.
It doesn't break. Or at least I didn't crash. No. Do I have errors? Yes, I have errors. Impact, check impact method not found. Are you crazy or what? What? Method not found? Oh, emit signal. Oh, I know. Now I know why I need that rigid body. Because when I collide, I will do a check impact. And the check impact needs to receive a rigid body. Okay. I remember why. So check impact is inside. I don't need to do check impacts in here. It happens only when on impact, so why I'm checking the impact? At the end of this, I set up the old velocity, and I just need to calculate the impact if I'm actually having an impact. A rigid body 2D, other even if I don't use it. Okay, let's see.
Prepare for main engine burn to decelerate as you approach the station.
It doesn't break. No, I'm not sure why, but maybe because the speed is too high or too low. Can I... Let's remove all these prints. And let's calculate, let's enable this again. And maybe the number is too high. No.
Prepare for main engine burn to decelerate as you approach the station.
Impact 0. Impact 0. Very nice. So ship velocity minus old ship velocity. Old ship velocity is configured at the end of the process, and ship velocity is being set up before, and we get the rigid body manager linear velocity length before. Linear velocity. This is happening inside a physics process. Okay, at the end of the physics process. and this is being updated every frame or every physics process frame. Okay. Ship velocity 0. Maybe I'm setting this old velocity in more than one place. This is what the start, the ready, okay. This is the declaration, and down here is the subtraction. So I'm not using this old. What I believe it's happening is even when I'm trying to order the things I'm doing, this is still happening in the same frame, or somehow I'm too tired to think. So maybe this is a problem for tomorrow. Let me see if the space explodes into the beginning of the other level. Continue orbit. Okay, now it doesn't explode. Now it doesn't explode because technically I don't even have speed. I'm always at a speed impact. Let's play it again and try to get into the orbit. Too soon. Why? A little bit difficult. Now I go out of the level. It's very difficult. That level is not yet. Maybe less. Yeah, a little bit less. Maybe it will be better. A little bit less mass to the planet. This will be very difficult to have 10 orbits around this planet if it goes this fast. So we need to start to fall before, and now we need to deaccelerate everything here. Whoa. And the planet is already outside of the level, and I'm only in the second lap. Third one. It will be very difficult to give 10 turns around this. But now it's not happening. One thing that was happening before, that was the spaceship was affecting a lot the speed of the planet. And now it's more realistic. Yes, one weight, one mass affects the other, but the planet is much heavier than the spaceship, so it shouldn't stop. Before it was stopping in the middle of the map. So I believe that is better right now. Let's go aggressive. No. Go now. Too much speed. Let's go. Oh yeah, but I need to go with the engine backwards, and I lose the level. That this will be difficult to play. So it needs to be designed differently. Okay, Godot index. Blah, 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 blah. No, yeah, this is the menu, and this is must be non-negative, and this is the menu having no more levels in the list, because when that's really roughly programmed, and when you fix something or you fail one or you do a level, it automatically prepares the next, except when you are at the end of the list you don't have any more, so it's not yet done. Okay, so today I guess I understood what the problem was and how to fix it, but it's not fixed yet, and mainly because this polar gravity, it has still a lot of stuff happening directly to the rigid body instead of go there. So I guess tomorrow we'll finish this, or at least we try to finish this. I try to finish this. At this moment, the spaceship no longer explodes again, because somehow this linear velocity or this calculation is not calculating correctly, so something is happening out of place, and this is always 0. But I have the feeling that the thing is more clear now, more clean. The things happens in a very specific place once, and I don't know, maybe it's better this way. So I guess I will end the stream, and tomorrow I'll try again. Yes. Sorry, wrong button. So yeah, tomorrow. See you tomorrow. See you in the future. Bye bye.